So we're working on some advanced techniques of integration, and what I'd like to do is give you a boost in the right direction, or a little nudge, on problem number 38, where we're expected to use completing the square to help us do this definite integral. So the idea is that we're going to use a technique of completing the square to make this into something that we can work with. Okay, let's do a little bit of housekeeping here first. This 2 up on top is just a constant multiple. So I'm going to just pull it out and rewrite the definite integral. And then the dx, that's just our differential, and we've been writing it out to the right. That's supposed to be plus 10. I'm trying to be a little better with the handwriting, but that doesn't seem to be working right now. So we've been writing that thing out there. So now we're focused on this function, 1 over x squared minus 6x plus 10. And because this is in the completing the square section, you know that completing the square is going to be part of our process. So I'm going to focus on that quadratic at the bottom. And essentially what we want to do is we want to start with the x squared minus 6x, and we want to insert something right here that'll turn this part into a perfect square. Now, we still have that plus 10. We can't get rid of it. So if I put plus something in, I also have to subtract it off. Okay, now the way we figure that value out that goes right here is to do half of this and then square it. So half of negative 6 is negative 3, and when you square that, you get 9. So I'm going to add 9 in here to make my perfect square trinomial, and I'm going to subtract 9 here to balance out the fact that I put the 9 in there. And so I'm going to squeeze it in on the screen here, but then I'll rewrite it on the next screen. This perfect square trinomial is just x minus 3 squared, and then this 10 minus 9 is just a plus 1. So I'm going to turn this expression, x squared minus 6x plus 10, into this expression, which is x minus 3 squared plus 1. Let me go to a new screen and clean this up for you. So from the work that we did on the last slide, we took the trinomial x squared minus 6x plus 10, we performed completing the square on it and turned it into what was x squared minus 6x plus 9 plus 10 minus 9. And when you clean that up, you get x minus 3 squared plus 1. So now, I forgot the limits of integration here. This is 2 and this is 4. So now what we want to do is we want to compute this definite integral. And believe it or not, it is now in a form that we can deal with. We are going to have to do a little u substitution first, but we can transform this thing. So my hint to you is to make u equal x minus 3, to go about converting this definite integral in terms of x into a definite integral in terms of u. Don't forget that we stay with u because u is good, so you got to convert your limits of integration too. And you can finish this definite integral off, and my hint is that you're going to need the inverse tangent. Okay, of u. So that's the little hint that I'll give you. But this part here is the key to being able to compute this definite integral. And that is that we use completing the square to transform the denominator from x squared minus 6x plus 10 into x minus 3 quantity squared plus 1. Hopefully that helped, and I'll leave this to you to finish the rest of the problem.